Hey everyone, so the title for these notes are arc length and area of sectors. Okay, so today we're gonna go ahead and start off with arc length and then we will go on to area of sectors. So let's start off with arc length. So what is arc length? To understand arc length, you first need to refresh the idea of the circumference of a circle. So let's go ahead and let's say that we have this circle. Here's the center, and then we have a radius r. And if I wanted to go ahead and find the circumference of this circle, the formula is circumference is equal to 2 pi r. So you go ahead and take 2 pi and you multiply it with whatever the radius is. Remember, 2 pi as an approximation is about 6.28, right? Because you take the number pi and you multiply it times 2, it gives you about 6.128, and then you multiply that times r. And that's just the general formula to finding the circumference of a circle. And remember, the circumference is the distance around the entire circle. Okay, now if you only wanted to find the distance of a piece of the circle, that's what we call the arc length. So let's go ahead and let's create like a piece of the circle. Let's create an arc length. And in order to do that, let's consider a central angle of theta. So let's go ahead and let's say that we have this angle right here, theta. And then we have obviously our radius r. Then the distance from here to here, that area is, that distance is the arc length that we're asked to find, and we're going to go ahead and call it S. Okay, well, I'm going to use S because that's the letter that they typically use when talking about arc length. So how do we come up with just that part? We don't want the distance of the entire circle. We only want what's in green. So in order to do that, I can just give you guys the formula, and I will, but I'm going to derive it for you guys so that you guys know where it comes from. And in order to understand that, you have to think about the circumference in regard to like proportion. You have to think about the arc length in proportion to the entire circumference and set that equivalent to your angle theta in regard to the entire full rotation around a circle. So let's create that ratio so I can show you guys. So that arc length S, we're going to create a fraction of this, putting it over the entire the entire circumference, which is 2 pi r. We're going to set that equal to the angle theta over the entire full rotation inside of a circle in radians, which is 2 pi. Now, in order to solve for S here, you're going to go ahead and use some basic cross multiplication. You're going to multiply S times 2 pi, and you're going to set that equal to theta times 2 pi r. And then to solve for S, to solve for the arc length, you're just going to divide both sides by 2 pi. This eliminates out, so you're left with S is equal to theta times r. And that is the formula to solve for this piece of the circle. Okay, so let's go back over here and let's fill in our formula. So one more time, if theta is a central angle, where make sure theta is in radians inside of a circle, and you have a radius of r, then the length of the intercepted arc, this length right here, which we call S, is given by this equation or this formula. S is equal to the radius times theta. Okay, so the most difficult part here is just remembering to turn your angle theta into radians if it isn't already given to you. All right, so let's look through examples 1 through 8. What we're asked to do is to find the length of the intercepted arc, which is pretty much the arc length, given the following angle measure and its radius. Give your answer in terms of pi, and you also want to go ahead and round your answer to the nearest tenth. So let's start off with number 1. In number 1, my angle is 5 pi over 6, and my radius is 3. So in this case, it is already given to me, my angle in radians, so I can go straight to using my formula. My formula, again, is S is equal to my radius, which is 3, times my angle, which is 5 pi over 6. So go ahead and multiply these, I can just put this over 1. Before you multiply numerator with numerator and denominator with denominator, feel free to do some simplification here. Obviously, 3 and 6 can be simplified to 1 over 2. And then now you can just multiply numerator with numerator, denominator with denominator. 1 times 5 pi is just 5 pi. 1 times 2 is 2. So the intercepted arc for this angle and this radius is 5 pi over 2. And in this one, it's given to us in feet. So 5 pi over 2 feet. To convert that to a decimal, all you got to do is use your calculator. I'm going to be using Desmos because I do not have a calculator here. So I'm just going to be putting 5 pi divided by 2. And that gives me the decimal answer of approximately 7.85. That 5 tells that 8 to round up to about 7.9 feet. All right, and that is how you find the arc length given an angle in radians and a radius. My iPad's already telling me to go to sleep. Okay, so that's that. 2 is pretty easy. It's very similar. They give you the angle in radians and they give you the radius. 3 is also similar. 4 is also similar. You all should be able to do those. I'm going to go over 5 because in number 5, you should notice here, the angle is given to you in degrees. It is not given to you in radians. So your first step is to convert your angle to radians. How do you do that? Well, quick refresher. Remember, there is a formula, but let's try to stay away from our formulas. If we understand where the formulas come from, there's a lot of less memorization that needs to happen. Let's just think about here. Let's think about what we know about angles in degrees versus angles in radians. So we know that a full rotation in degrees is 360 degrees. That is the same thing as 2 pi radians. Those are equivalent. So let's think about what a half rotation is. So let me go ahead and take this and divide this by 2. Let me take this and divide this by 2. 360 divided by 2 is 180 degrees. So a half rotation would be 180 degrees, which is approximately equal to 2 divided by 2. Those 2's eliminate out, and I'm left with pi radians. So a half rotation, 180 degrees, is equivalent to pi radians. Now, in order to convert this angle that is in degrees into radians, I need to figure out how many radians are in 1 degree. Because once I know how many are in 1, I can go ahead and just take that and multiply it by 15 to figure out how many are in 15. So to do that, I am going to divide both sides by 180. 180 divided by 180, that eliminates out and simplifies down to 1 degree. So we know that 1 degree is approximately equal to pi over 180 radians. So if we know that 1 degree is pi over 180 radians, then 15 degrees, I would take that 15 degrees and multiply it by pi over 180. I'm going to erase that degree symbol because it looks a little funny, to figure out how many radians are in 15 degrees. So to solve this, you go ahead and again, just put this over 1. You multiply numerator with numerator, denominator with denominator. You can simplify here first if you'd like. 15 pi over 180 simplifies down to pi over 12. Okay, so 15 degrees is equivalent to pi over 3 radians. So now that you have your angle in radians, you can go ahead and just use your arc length formula, which tells you the arc length is equal to the radius, which is 8.4, times the angle in radians, which is pi over 12. This obviously simplifies down to 8.4 pi over 12. That can actually be simplified here. I would recommend just using a calculator though, just to always verify, because that is kind of unnecessary algebra. So you can put 4 divided by 12 onto Desmos. And then you see how it gives you a decimal. When you don't want a decimal, you can hit this little fraction button right under that number 1. And then you notice that it turns it to 7/10. So 0.7 is the same thing as 7/10. So this would simplify to 7 pi over 10. And this one is in meters, so it'd be meters. To convert that to a decimal, you just go back over here and you add the 7 pi over 10 to get your decimal, which is approximately 2.19. That 9 tells that 1 to go up. So this is approximately 2.2 meters. Okay. So that's arc length. What's most difficult, or what you need to remember most here, is to remember to turn your angles into radians. You might need to also remember how to convert degrees into radians. And I know that this is a lot of formula-based things, but guys, if you try to just do more for understanding than memorization, these formulas don't really need to be memorized because you can just derive them yourself, right? So to come up with the arc length formula, you can just go back to determining what the in general circumference of a circle is and what the general full rotation of a circle is, and then put that in proportion to whatever they give you to come up with the arc length formula. Similarly with how to convert degrees into radians and radians into degrees. Okay, let's go ahead and, I don't know if I need to do one of these word problems with you all. I might need to. I guess I can do like number 10. So in number 10, we have a merry-go-round that rotates 2,808 degrees per ride. It says how far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So essentially, it might help you to draw a picture here. You know that merry-go-rounds are circular rides. And we're given that we have a rider that is seated 8 feet from the center of the circle. So here's our little rider going on the merry-go-round, and this person is 8 feet away from the center. And we know that this person is going to be going around at an angle of 2,808 degrees per ride. So obviously, are they going around more than once? They definitely are, right? Because all the way around is 360, but they're going again and again and again. They're going up until 2,808 degrees. So their angle will be somewhere, ending somewhere on this circumference of this circle. So the question is asking you, how far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So that's essentially asking you to find the arc length of a piece of a circle that has an angle of 2,808 degrees and a radius of 8 feet. So your first step is to convert 2,808 into radians. And to do that, remember, you multiply this angle by pi over 180. You can just type that directly onto the calculator to get your answer. So you can put 2,808 over 180 to figure out your simplified fraction. Hit the fraction button to convert it to a fraction, and you get 78.5. So this is 78 over 5. So it'll be 78 pi over 5. That's your angle. And then once you have your angle in radians, you can go ahead and use your formula, which is S is equal to the radius, which is 8 times 78 pi over 5. And for this one, since it's a real life application, you can honestly just go straight into decimal mode. So you can just put 8 times 78 pi over 5. And that gives you approximately 392.1 feet. Okay, and that is the distance that the rider will travel. All right, so that's arc length. Let's go on to area of sectors. So I actually had already done some of the algebra here off to the side. Because like I said, I even myself, I like to derive the formulas myself so that I don't have to memorize these things. So what is area of sectors? So pretty much the area A of a sector of a circle with radius r and central angle theta is given by this formula. It's A is equal to 1/2 theta r squared, where again theta is measured in radians. But you can derive it. You can derive it, and I'm going to derive it for you guys off to the side so that you guys know where these formulas are coming from. So in order to recall this formula, so now we're talking about area. So again, if I have this circle, all of this that I've highlighted in yellow is the area of the entire circle. Now, the area of a sector is pretty much when I don't care about the entire area. Maybe I'm only caring about like this part of the area of the circle. So again, to derive that formula, you have to think about the entire area in regard to this angle theta, and then compare it to just the inside piece that you would like. So we can call this inner piece big A. So we're going to have the inner piece over the entire area, which is in yellow. And if you don't remember, the area of a circle is equal to pi r squared. So this would be the little piece A over pi r squared is equal to your angle theta over the entire rotation, which is 2 pi. Again, you do some cross multiplication here. A 2 pi is equal to theta pi r squared. To solve for A, which is that little piece, that area of a sector, you divide both sides by 2 pi. In this case, the 2 pi's eliminate out. Then you get A is equal to, in this case, only the pi's eliminate. So I have theta r squared over 2. Now, this might not look exactly like what we wrote over here, but it's the same thing. All they did was that over here, they pulled out the 1/2. And then you're left with theta r squared, which is the same thing that we have right there. Okay, so again, don't feel like you guys have to memorize these formulas. Just think about where they're derived from, and you don't, and then you can come up with it yourself. So let's go ahead and use this. So we are going to be asked to find the area of each of the sectors shown. The sectors are what's shaded in gray. So you're not finding the area of the entire circle. You're only finding the area of that shaded sector. So, like I said, theta, you need to make sure that theta is in radians. This theta is not in radians, it's 74 degrees. So your first step is to convert 74 degrees into radians. And the way that you do that is you multiply your angle in degrees by pi over 180. So you're going to take that and you're going to multiply this by pi over 180. Just use your calculators. This will essentially, you can type in 74 over 180 onto the calculator on Desmos and then get the approximation, which should give you 37 over 90. So this will be 37 pi over 90, and that's your angle in radians. Now to find the area, you're just going to substitute it into your formula. So you're going to have A is equal to 1/2 theta, which is 37 pi over 90, all times r squared, and your r in this case is 4. Now this, you can just type this directly onto your calculator, or you can do it piece by piece. These directions do not tell us to have it in exact form and decimal form. So honestly, just going straight to decimal form is okay. So obviously you can multiply like this fraction with this fraction first if you'd like. 1 times 37 gives us 37. And then 2 times 90 gives us 180. So you'll get 37 pi over 180 times 4 squared, which is 16. And then at this point, you can just go onto your calculator and you can type in what 37 pi over 180 move the arrow off to the side, times 16 is, and get that decimal of approximately 10.33, which will just round to A is equal to 10.3, and this is centimeters. Since we are talking about area, it'll be centimeters squared. Alrighty, and that's how you find the area of sectors. Just making sure to turn those degrees into radians before you use your formula. All right, other than that, I think we should be good. You should practice the rest of these questions that I didn't do and let me know if you have any questions, but that is how you find the area of sectors and how you find the arc length of circles. Thank you.